Okay, on Friday, what were we doing, guys?
Oh no, it's homework help.
Strategy. Oh, yeah. We're on homework help because on Friday, didn't we cover the notes for section 3-4?
Yes.
And we said, hey, here's what solving has been. Just one-to-one properties or maybe inverse properties. Undoing. And we saw some quick examples and we were like, hey, how do you solve each of these? And most of them were fairly straightforward. They were all using the inverse and the one-to-one. That's where we had been. But then it was like, hey, things might get, even though we are still supposed to use those old properties, things might get a little harder. You might have some extra stuff that you have to move away from the exponential or the logarithmic piece in order to be able to solve. So step number 1, remember, get the exponential or logarithmic alone, if possible, on one side. Okay? Then look to all the properties. But look to the one-to-one property, because if it works, man, it's going to be easy to solve from there. If it doesn't work, ruh-roh, somehow we have to get rid of the exponential or we have to get rid of the logarithmic. Probably using inverse properties, but there might be other ways as well. Now, if you guys remember in section 3.3, didn't we also learn how to sometimes expand or sometimes condense logarithms? That might be important today also. So then we started on examples, and I was like, hey, why on earth are we taking a whole nother day if we start on examples? Usually it's right before the end, right? Look over here on the left. How many pages of examples? Oh, man, until the homework.
4, 5.
So what's our day-to-day going to be consisting of? Homework help, right? AKA looking to see, okay, fine, how could it get any harder? And all we did on Friday were these 2 examples. How did it get any harder? Well, was A really any harder? Look at A. Not really. It was just move it all to one side, factor, and solve. Okay. Was B any harder? Well, kind of. All you had to do first was what? 6. No. Some of you would try, look, do you see the mouse, the cursor? Don't look at me, look at it. Some of you say 6, yay, boo, no, because PEMDAS says exponent, then multiply, E, then M. Can that happen in one step? No. So here's the dealio. 2 is to the X, 3 is to the 1, and they are different bases, so they cannot combine. You guys say it. They cannot combine. One more time. They cannot combine. So don't do it, okay? I haven't made an animal out of this rule. If I made an animal for every algebraic mistake you could ever make, there would be way too many. Maybe I should go to Job and use those. But anyway, coming back. Divide by 3. Isolate first, and then solve. Does that make sense? How did we get rid of the 2 to the power of? What did we do? We put ln, or we could have just said log base 2 of both sides, right? And it would have canceled to x. So that's one way, log base 2 of both sides. Or you can just use ln both sides. The x pops down from the power property, and then you divide. And these mean the exact same thing. But which one do I like better? That one. Poor K. In calculus, what did I tell you was easier? ln's. Okay. You guys. Ready, set? It's easy, cheesy stuff, right? Go.
Probably not.
Oh, it's right here waiting for you. I graded it.
Totally
Here
wrong.
you go. Thanks for saying something. I would have. Ready, set, go. These 2 are still pretty easy. The hard ones are fun. And the nice thing is today's a work day in some senses that we're going to work real hard and then hopefully homework will be real easy. Really easy? I don't know where my adverbs went. Close it. Yes, how'd you guys like Apple? Yo también. But I get him every Sunday, so I guess I can't really.
You're lucky.
I meant the messenger. Okay.
Yeah. It was good, but
Anyway, if any of you guys don't have a normal church gymnasium here on Sunday, you guys can find it because you know where it is. 10:30. Yep, that's where our church meets. He's the pastor. Our church is Christ Bible Church. The Regans go there. I go there. Katrina started going there. The Hodgsons go there. You guys know them?
Yeah.
You know them? Anyway, you're always invited. Not that we want to pull you away from other churches. This is no such place. You guys got him? You got the first one. All right, keep going. Get the next one.
I heard that was gonna be the high school.
I heard that Luca would be what?
By the way, Luke, I heard congratulations are in order that you had a good game on Friday.
I missed the
Hey, how far was that kick?
55 yards.
Okay. We are still extremely proud of you, so good job.
3 feet. 4 feet.
We are still very proud of you.
I heard it was gonna be high school record. Imagine. That'll be dope.
Well, and you were only 3 away. That's
Get the W in the record.
people were bragging about.
Worth it. I could have made a 53.
It's crazy.
I'm mad. I'm putting my LA wheel anyways.
You should. It shows the distance you can get.
We had 2 seconds left.
All right, guys. It was easy cheesy, right? That's why we're just chilling. All right. What'd you do for A?
Put a big ol' E.
E. A big ol' E on that side. Big ol' E on that side. E to the ln. E to the log base E. Cancels. X equals E squared. Done. Why is it not a decimal? Because who wants to put a decimal when you can put E? Okay, so letter B. Oh, this one was rough.
Sure.
Not really. Sure. It has like bases.
How could you do it? One is to remember a property and one is to do some math. Okay, so one-to-one property of ESA, what's it say? Oh, you're actually doing the math. That's what Luke's saying. So Luke's doing the math and Isa's saying the one-to-one, but let's start with the math. Luke, what are you saying we could do? Big ol' 3 and a big ol' 3, and what happens? That cancels, and you end up with, but Isa, where could you have jumped to with the one-to-one?
That.
Right? So the one-to-one property, you don't technically have to do that, but does this kind of explain what's going on? Yeah, sure, either way. And then, oh, we have to solve. Bummer. Subtract and we get 4x. Add and we get 8. Solve and we get... Dun, 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 dun. Oh, sorry. No, it's okay. I figured you didn't have one, but... Woo! Did it get a little more exciting?
Of course it did.
Why? How can I tell straight away without even looking at the examples it's more exciting?
Approximate.
Why would you need decimals if the answers are nice?
Because you're probably going to use your calculator. Yeah.
Okay. Pause and wait. Number 28. How should you start?
Distributed property. Just kidding.
Divide by
Just divide by the exponents.
Divide!
Yeah.
Guys, you're gonna like lead someone astray. Bad shepherd. What's it I would call it? Hireling? When he's not the true shepherd, he won't really care so when trouble comes. That's the devil. Okay, so, no, literally.
Well, Kristen, you went so bad right now.
Wolves in sheep's clothing. How do we solve? What's one thing we could do?
6 minus x equals log base of 35.
We could change it. Karina's saying that there is a property. Remember, exponential can go to logarithmic can go to exponential. So we can say base 3, so we could say log base 3. Back forth of 5 equals 6 minus x. But a lot of you are like, yeah, no, my brain did not go there. Okay, so hold on. What's some math we can do to solve this? How do we undo a 3 to that?
Oh my goodness. They'll tell me we have to do 6 plus x in the exponent.
No, it's not that hard.
Okay.
It's not that hard. I mean, we could do something like 3 to the 6 over 3 to the x, and we could break it up because 6 minus x, that's the property. And that'd be pretty cool. But most of you are like, I don't like that. Okay, fine. How do we undo a 3 to the power of? You guys know this.
Log base 3.
Log base 3. So you could take log base 3 of both sides. Now, that's personally not my favorite, but you could. Log base 3 and log base 3. What happens to the log base 3 of 3 to the power of? 6 minus x. And then, hey look, and we didn't have to remember that whole back and forth thingamabob. Okay. Either way you do it, whether you remember, like Karina, the whole back and forth between exponential and logarithmic, or if you remember, I can undo a 3 to the power of with a log base 3. That's the inverse operation you get here. And then you would solve. Some of you would solve a little bit funnily. Funnily? Funny-ish? I don't know how to make that an adverb. Strangely. There you go. Stranger things. Anyway, how do we solve for x? Subtract 6. That's one.
Divide by negative.
And then divide by a negative. And you actually end up with a 6 minus log because the signs switch. The way I kind of like doing it. And you don't have to do it the way I do. I don't like a minus x, so I add an x, because my head can do that, and then it says, oh, subtract him. Ta-da. You don't have to be completely conventional and always leave x on the left. Is that a correct representation of the answer?
Sure.
Yes. But do I like log base 3s? I'm not saying that you can't use them. I'm not saying that it's wrong or a sin. But I am saying there might be a better way. And my better way would entail not taking log base 3 of both sides, but doing what instead? What instead?
LN.
ln.
But how does that work? That doesn't cancel out. No, it doesn't. But what's the property say of logarithms? So you could get 6 minus x ln of 3 equals ln of 5. Then you divide by the ln of 3. Yes, there is an extra step, but I'm just trying to remind you there are different ways of add the x, subtract the rest. There are different ways of representing the same thing. Technically, how could you go back and forth between these two answers and say, oh yeah, of course they're the same? What formula helps us go from here and understand? Change of base. Change of base. There is a formula that says log base 3 of 5 and ln of 5 over ln of 3 is the exact same. So, whether you use log base 3s or whether you use ln's, either one will get you to a proper answer. Now, just for sake of color coding and for those who are not here, let me really quickly just make all of him green. That way it goes with the green one. Dun, dun, dun. I don't know what green it is.
It's like
That one?
no.
I think the middle one.
No.
No, it is.
It is.
See, it always looks darker up there. It confuses me. Okay, so we're amazing. We're on top of this. We're kind of getting it, right? So the next one, easy. Easy. What's the struggle if you always stick with log base when you get to this problem? What's the struggle?
You don't have like bases.
I have two different bases.
Put LN.
What am I supposed to do with that?
Put LN and then bring the exponents to the front.
You don't have to do the log base of one base. You can just use LNs and say whatever. So the whole base thing's not working out. But the other one, look, the x comes down and then the x plus 1 comes down.
Can it come down even if you do like a log base of 10 or something?
I just like LNs better. But yeah, you could have done common log. You could have done log base 7 or 2 worth. Then you end up with x ln of 2 equals x plus 1 ln of 3. Now some of you are still just as lost. But wait. Does putting any logarithm and using the power property kind of make sense? Put any logarithm. I use ln because I'm telling you for calculus he's the best. But you could have put any log there and these would have popped in. The struggle is what do we do next? There's an x on both sides. We've seen this, we just haven't seen this with messy things like this.
Divide by ln 2.
Ooh, I wouldn't divide. You can. You can.
Dude, I
But usually the process,
Do you subtract
Maybe-
like one side one to the other side.
Just the 5
No, because
What
it's
if
a
we did the
multiplication.
thing with that big E? What if we did a big E?
But there's something in front, so it's not going to help. It'll just come back here, sadly, because then we need to pop it up, and then EE, and then we're right back.
Yeah.
Good idea, though. We could do some division, but doesn't multiplication and division usually make things more complicated? The x is stuck. I need to get the x out of the parentheses, and the only way to get rid of parentheses is to what? You just don't like it. Too bad. You got to get rid of those parentheses to get to the x, so you distribute. You say, all right, fine, I have x ln of 3 plus 1 ln of 3 equals x ln of 2. Now can I move the x stuff to one side? Yes. Doesn't mean you like it, but you can. And x was stuck in a parenthesis. We had to get it out of there, so we distributed to get rid of the parentheses, and now we start solving. So then we can subtract it. X ln of 2 minus x ln of 3 equals ln of 3. Hey. Aw, stink. I can't put them together because they're different. Well, how do you do ln of 2 minus ln of 3? I don't know. But what can you do?
Divide? No.
You can combine them.
How?
Because it's the subtraction property you can use.
Ah.
You could have,
The only way to combine with subtraction is to get rid of it and put it in powers, and we can. I'm going to show that in a second. But right now, just algebraically, if we have two x pieces on one side, how do we get the x alone? There it is. And look, isn't he alone? We end up with x equals ln of 3 all over ln of 2 minus ln of 3. Or I think, as Karina's been seeing, ln of 3 over ln of 2/3. How do I get 2/3?
Now you can combine.
The subtraction I can make into a division. Because there's nothing funny showing in front.
and that because they have the same basis, right?
If you just left it with the ln 2.
I'll box both. I'll box both. I'm just letting you know, like, okay. You can think about for a test that's coming soon, Friday, because you guys didn't want Thursday to be evening. You could think on a test, isn't there like one multiple choice you're trying to match it with? So I might not have both forms. And if I do, then it's a trouble because they're both right. So there's going to be only one form. But then think back right now to homework. What are you guys checking with? That's only usually writing an answer one way. The back of the book or couch on your Slater or something. Other people that hopefully are doing it right. Okay, so whoever you're checking it with, it's kind of the same thing. If you get this answer, you just have to figure out, is it the same? Does that make sense? And if you can make it match, that's a key phrase in calculus because we're all going towards, not all, but we're going towards an AP exam. Most of it is multiple choice, half of it is multiple choice. And it's sometimes hard to make it match. So the first step, get it right. Second step, okay, could I make it match if I needed to? Is that cool? Kiddos, what have I not done the directions technically told me to, but I just didn't want to take time for? Okay, fine. Do you guys know how to do that? Type it into your calculator and hit enter. Can we do that? On our own? Okay, let's keep going. Number next one. Remember, we have pages to go through. Ah! Why is this a hard page? And the nice thing, Jesse, real quick, if you typed both into your calculator, they would both give you the same decimal. So that's one nice way to make it match and make sure. Oh, I'm not talking about the test right now. Homework test is still the jury's still out. Okay, so factoring problem. Why not just put those two together? No big deal, right? They both have e's.
Yeah, but that one is.
Well, there's a 5 in front, and then those are different. They're not like terms, and then, okay, that's illegal. Don't put it together. But how on earth could Karina be saying factoring? That's e to the, not x
Oh,
to
you
the.
improved it. -2 and -3.
You're going this way? That's a good idea. Negative 2 e to the x and negative 3 e to the x. I mean, most of you could probably just say 6 and 1. But either way, we could group it, if that helps. E to the 2x. Question, what could come out of that one and what could come out of that one? That one's easy.
E to the x.
That's a 3, right? What could come out of the other one?
E to the x.
Oh, you can pull away just 1? So this is really e to the x squared? That's why you can factor. I have somebody squared minus 5 times somebody plus 6 equals 0. Or if you want to look at it differently, if you're like, I don't like the e to the x. He's making it look all gross. Fine, guess what? He can be rewritten u squared minus 5u plus 6 equals 0. Where e to the x is u, or u represents e to the x. And you can say, sweet. U minus 6, u plus 1, u equals negative 1, 6, and then you say, plug it in, e to the x equals negative 1, e to the x equals 6. We'll come back to him in a second. What would happen if we kept going over here? Pull out an e to the x, well, how many is left? Yeah, 1 e to the x. Pull out an e to the x, who's left? And then we say, e to the x minus 3, e to the x minus 2. Oh, I struggle. What was that over there? Question. Some of you make this very same mistake. What's negative 6 times positive 1? Does it match? No. It's a struggle when two factors can make 5, but very different ways. If I had factored him, closely properly, then it would have worked out a little bit better. Equals 2 or 3 equals 2 or 3. This one says forget the e's for a bit, but you better come back. This one says keep the e's. It looks a little confusing, but guys, how would you solve at this step? So each one equal to 0. So you would get e to the x is equal to 3 or e to the x is equal to 2. Did the method make a difference? No. Now are we done?
No.
No, but we're close. What am I going to do? And why is it good to use ln this time? Like it's extra good to use ln. It's an e, which means it's going to cancel out. And that's the exact same thing I would have done if I had done it this way. The one on the right is for those of you that are like, there are way too many e's over there. All right, we can ignore them for a bit and then come back to the e's. Over here, it's like, whatever. They're there. We'll deal with them. But either way, at the very end of the day, you get x is equal to ln of 3 or x is equal to ln of 2. Both of them would make 0. And over here, you get the same thing. X is equal to ln of 2 because e and ln cancel out. X is equal to ln of 3. Either way, works just fine.
The only problem with this chapter is like you don't know if you're done. If you can go further.
Yeah, sometimes it's hard to know when to stop. And sometimes when they say simplify, it's like you kind of simplify, but then you have to check and make sure. Which is why sometimes on the test you should stop with whatever answer you have before you keep going and see if it matches the way it is. And then if not, if things look a little more simplified, like, oh, I better keep going. How many of you guys just looking at the screen are like, I think I can handle the left? How many of you guys are like, too many e's, I'm just going to go for the right? And all of you are undecided. Just kidding. It's up to you. Just see what I did one more time. What made factoring in either form necessary? The 2x. I think Nicole, you said that at the beginning. The 2x makes factoring necessary. It's a quadratic. It's just kind of hidden. But these two are different. Like bases, but different powers. How do you put those together? Factoring is the best way to go. One way says, I'm just going to work with the e's. And some of you could have maybe jumped here without all this grouping stuff, but the grouping might have helped you see. Jump to the factoring. Others of you are like, gross. I'm going to let u equal the e to the x. Get that e to the x out of there and just look at the quadratic. Factor him, put the e to the x back, and then solve. It's your choice. It's your choice. Just keep it legal. Go to the next one. Go. I'm not even going to talk to this one. Let's see how far you get. And technically, even though the book might say go to the decimals, because they're just trying to show you, you might have different forms of the answer. If they get the same decimal, you have a correct form. I would rather you just leave it, at least in the example in class. I'm not saying how to do it, I'm just giving a reminder. Our first step for solving equations is isolate. Take the part with the x alone. And you cannot say 2 plus 3 is 5. Check your work if you did that. It is supremely illegal. Multiplication gets done before addition. The 2 cannot combine with the 3 because the 3 is times the ln. You cannot make it 5. If you can't make it 5, what had you better do with the 2? Get rid of it. Do anything else with it. Then what?
Execute.
You could have done that too. We'll see if it works out this one. Then what? Now I'm going to go ahead and draw one arrow because Luca had an interesting approach and he said it works. Let's check it out. What if we start with the exact same problem? Did you subtract the 2 still?
Yeah.
Okay. And he got to 3 ln of x equals 10. So he subtracted the 2. What'd you do next?
I put the 3 back instead.
He said ln of x cubed. Then what?
Then I put a big ol' E.
A big ol' E. X cubed equals e to the 10. How do you undo a cube?
Yep, the square cube.
Now, here's a question. What if you plugged both of these in the calculator? Guess what? They're the same decimal. So that's how you check. They're the same decimal, which will be the same decimal as the back of the book. But can you also maybe see how they match without a decimal? A root is what kind of power? A fraction. This is the whole power on top, and that's the radical root in the bottom. Brandon, we're just doing homework help, bud, so we're just doing examples for the homework due tomorrow, so you're good. If you want, you can just pick up where we are, and then we'll have the video. All right, we got it? You guys were flying. Ooh, ooh,
That
man.
looks too long.
Y'all are just afraid.
I know. 60 seconds from right now. Don't talk to each other, but ponder how to start. And there are different ways. Illegal, some legal, others more than one. Still 45 seconds. How would you start? Get a first step. Yeah, go ahead.
Would it work if you added the other side and then did one for one property?
Almost. But that is a common mistake. Jesse, it would have worked perfectly if only there was just a 0 on the other side. Can anybody explain why, since there's not a 0 on this side, I can't just add the other log to the other side and do the 1-to-1 property? Why can't I just say x equals x minus 1? See it? If it was a 0, that'd be perfect. That's the easiest, the best way to go. Oh, there's a 1/2.
What if you put it in the
Exponential form you could almost do, except I have 2 different logs. And I can only change to exponential form if I have a single log. So if you can get a single log, then that would be a good way to go.
That's what I did. I did log base 4 of x over x minus 1. Because you want a monomial in each side.
You want a single log. Now what property allowed Luca to do that? X over x minus 1 in a single log 4. Log base 4. Quotient property. Yeah. Is that legal? Mm-hmm. But how many of you, just wondering, how many of you thought maybe I should put a big old 4? Right? Okay, so what happens if I put a big old 4? Now, it's a little trickier. Technically, they both end up going the exact same direction. And both of them need properties. One of them of exponentials and one of them of logarithms. This one, quotient property of logarithms, allows that to happen. This one, well, okay. Totally illegal to say, whatever, cross, cross, I know there's a minus, but who cares? Bad idea, okay? Whatever you're doing, I don't think it works, but I'll try. It's usually not going to work. But what's true when you have a single base with a subtracted power? Can you guys go backwards in the exponential rules? When do the powers get subtracted? Division. So you could have rewritten it. Subtracted powers comes from division of like bases. Now that's 50 because you're like, oh, sweet. Look. Well, that's going to cancel, and that's going to cancel. I get x minus, wait a minute. What did I do that was illegal? If I find it, find the error.
You didn't write the big old 4 in the
I wrote
other
the
side.
big old 4 there, but where's the big old 4 over there? All right, hold on. Let's get our big old 4. Big old 4 on one side, big old 4 on the other, right? How many of you would have caught that if I hadn't said anything? Just be careful. Now I have x over x minus 1 equals 4 to the 1/2. Well, wait a minute, isn't that different? Oh, how would you keep going over here? Brings it to 4. Hey, look. So the quotient property of logarithms is the same thing as the division property of exponents? Yeah. It is. And that's where it came from. You probably don't remember, but we kind of showed where it came from, and that was it. Okay, well, here's the struggle. 2 different approaches let us straight back to one single way of solving. So how do we finish this puppy off? 4 to the 1/2 is 2. How'd you do that? 1/2 times 4? 1/2 power is a square root. So square root of 4, right? So I can have x over x minus 1 equals the square root of 4, which is 2. How do I solve x over x minus 1 equals 2? Good, right? You gotta split up that division. He's not working right now. So then multiply by the other side. Are you cool if I'm totally legal and distribute the 2? Then we subtract the 2x, we get a negative x equals negative 2x equals, that was intense.
So you see, you insert the square root. So why is it not plus or minus?
Ooh,
Because it
but I didn't I didn't insert the square root, like to put in a square root to undo a squared. I rewrote what was already there. And since the 4 was positive, then I can make it a positive square root. That doesn't make sense.
No, it does make sense. That you
But the
rewrote-
positive 4 just means positive 4 underneath. If it was
You
a
already
negative.
had a positive with the 4, so then
That kind of works. Kiddos, here's the struggle. You ready? If you checked in the back of the book, guess what the answer would be?
whoa. Blah.
Oh wait, that's a mathematical word.
Blah.
Kind of seen since not that one, that one. Have you seen since algebra 1? That you've seen since algebra 1. What did extraneous solution mean in algebra 1? Extra.
Extra.
You get an extra answer that looks like it's right, but when you try to go plug in and check, it's impossible. What? But the math, it was great. Yeah, but what did we do? We took away the what? What did we take away? We took away the logs. Struggle. But what's true with logarithms? And I don't know if you've actually written this down, so we better get this down today. What's true with logarithms? They have a what? Because they have a vertical asymptote at 0. You cannot take a log of a negative number. It is impossible. You can't raise a positive number to a power and get a negative number. Mathematically, it doesn't work. So, whatever's inside of a logarithm must be greater than 0 because there's a vertical asymptote at the 0. Maybe a good thing to write down. Domain problem. Now we have a third. But what does that mean with 2? What's the big dealio? When we go to check, I don't know what color to use anymore. When we go to check, I've used them all. When we go to check, what happens when we plug in? Log base 4 of 2 minus log base 4 of negative 1 is equal to 1/2. No big deal, it's going to work. Is this possible? Does not exist. If you plug in 2 minus 1. Oh, struggle. Except I can't subtract. Oops. So guess what the answer in the back of the book is? Wrong. No, the answer in the back of the book is 2. I didn't look. I just made it up. Never mind. But if, I think it comes somewhere in homework, and I really hope this was an example, and I thought I had it. But I did 1 minus 2 instead of 2 minus 1. Order matters. PEMDAS. Anyway, give me back. The 2 works, right? And the 2 works. But what if we went to go check and it made a negative number? What would we have to say? None. Don't write the blah, but extraneous. Okay? Why? Because of the domain problem. Do we have any more? Oh, we're done. Dun, 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 dun. Homework 21, right? Yeah. Okay.
So if the stuff is really practice, like we need a lot of practice.
If you want your test or grade, you can come in and get them after school. Otherwise, beginning of class tomorrow, I'll pass them out with correction papers. Corrections are due probably Monday because the test is on Friday. Sound good? Okay. Bye, guys.
Bye.
Happy end of period. Already 3. Let's get you guys confused.
Oh my goodness.
Happy Monday. You're almost there. Keep plugging. Keep it chugging.
Oh,